Ladies and gentlemen, we are back with a little bit of geometry. In today's lesson, we are talking about angles. We'll be looking at problems like this one with supplementary angles. So title your notes. 1-6, describing pairs of angles. Complementary and supplementary angles. Complementary angles. I remember these by thinking of they are like a corner, right? In the corner of a room, most corners are 90 degrees. So complementary, think of corner, they add up to 90 degrees. Now they don't have to be adjacent, it's just two different angles that add up to 90 degrees. That's how you can remember it. Supplementary, I think of straight. Okay, supplementary add up to 180. 180 would be a straight line. Again, they don't have to be adjacent. They could be two different angles as long as they add up to 180. So supplementary is the straight one. Complementary is the corner. Adjacent angles, I mentioned this a couple times. Adjacent angles are angles that are next to each other. So they have to have a common side and a common vertex. Notice they cannot have common interior points, so they're next to each other. We call 5 and 6 adjacent angles. These two, 7 and 8, are non-adjacent. They do not share a common side. Alright, identifying pairs of angles. In this figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent. Okay, complementary, remember, is the corner. So we want them to add up to 90. So which ones here add up to 90? We have BAC and RST. Those are complementary because 37 plus 53 is 90. And then CAD and RST, those add up to 180. So those are supplementary angles. And then finally we have adjacent angles. These two, BAC and CAD, are adjacent. Alright, here's our soccer example. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles. Remember, supplementary is the straight angle, adds up to 180 degrees. So it says find BCE, the measure of angle BCE, and the measure of angle ECD. So we'll find those measures. We know that both of these add up to 180. Measure of BCE plus measure of ECD are 180, so we can replace those. Substitute BCE for 4x plus 8, and then ECD for x plus 2. We can combine 4x and x to give us 5x, and 8 plus 2 to give us 10. Subtract 10 from here, we get 170. 170 divided by 5 gives us 34. So x is 34. Now that's not the measure, though, of this angle. Be careful. Do not stop your problem here. We need to plug x back in. So take this x, plug that back in to this one to find the measure of BCE. Okay, so plug that into 4x plus 8. 4 times 34 plus 8 gives us 144. So that angle right up here, this one is 144. This one's going to be an acute angle. Plug 34 in for x here. That one's pretty simple. 34 plus 2 gives us 36 degrees. All right, linear pairs and vertical angles. A linear pair, just as the name says, a line is a pair that forms a line. Okay, so 1 and 2, they have one common side and they form a line. They have opposite rays and make 180 degrees together. So if I look at these vertical angles, two lines, and then opposite of each other, formed by the intersection of two lines, are vertical angles. So 4 and 5 are vertical, and 3 and 6 are vertical to each other. Angle 3 and angle 6 are vertical angles, 4 and 5. All right, identifying pairs. Example 4, identify all linear pairs and all vertical angles. Linear pairs, remember, is the line. So we're looking to see which ones are on a line and they share a common ray, common side. So 4 and 5 are a linear pair, and 1 and 4 are a linear pair. And then we want to find vertical angles. Vertical are across from each other on sharing the same two lines. So 1 and 5 would be vertical angles because they're across from each other. So angle 1 and angle 5 are vertical, and 1 and 4 and 5 are linear pairs. All right, finding angle measures in a linear pair. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of the angle. Tip 1, always draw yourself a little image. That way you can imagine that if you just have this text, draw a linear pair. So start with a straight line, and then draw one that's a lot bigger than the other, 5x and x. Remember, these two add up to 180. So we're going to do 5x plus x equals 180. I can combine those to 6x is 180, divide by 6 on each side, and I get x equals 30. We want to know the measure of each angle. So this one is 30. This one is 5 times 30. So that one's 150. All right, interpreting a diagram. Very important. You can't always conclude certain things from a diagram, even if it looks like it, even if you're pretty sure it is. If there's no specific indication, you can conclude. Now, here are some things you can conclude from this diagram. We can conclude that all of these are in the same plane. We can conclude that ABC, that AC is a line, that BD, BE is a ray, and all of those intersect at point B. Okay, here's some things that we can conclude. That B is collinear with A and C, and B is between A and C. That D and E, angle DBE and angle EBC, we can conclude that those are adjacent, and that ABC is a straight angle. And that point E lies on the interior of DBC. What we cannot conclude is that AB and BC are congruent. Okay, we can't tell that. It might look like these are the same length, but there's no indicator of it. It would have to have a line like this saying, okay, these two are congruent, but that line is not there. We cannot conclude that this angle is congruent to this one. Okay, there's no indicator of that. We can also not conclude that this is a right angle. There's no indicator. It would have to have a symbol there. All right, so be careful of those things. Aside from that, that is all we have for today, ladies and gentlemen. You are one step closer to being a mastermind. Chapter 1, Section 6, Describing Pairs of Angles.